Hello Gators, this is 5.1 using the mean value theorem. Let's go ahead and discover the mean value theorem by following the directions here. They want us to draw the secant line and then try to draw all the tangent lines parallel to that secant line. So I'm going to draw the secant line and then draw the tangent line that's parallel to it. Draw the secant line and try to draw some tangent lines that are parallel to it. Over here, draw the secant line, and I'm unable to draw any tangent lines here. Draw the secant line, and again, I'm unable to draw any tangent lines that are parallel to that. Here, I don't even have a point A, so I'm not even going to try. Here, I'm going to connect. This is the secant line, and the tangent line does not exist because I can't use that point. So only the first two was I able to do this. Let's go ahead and draw the secant line between these 2 points. I'll go ahead and do that. And then I'm going to estimate to draw tangent lines parallel to this line, like right about here. And that's about at 3, a little close to 3, about 2.9 I'll say. And over here I'm going to draw the secant line and then draw all tangent lines that are parallel to that secant line, and that's located around 2.5, and the other one is right about here, about 4.5. I'm going to do it over here, draw the secant line, and then draw all the tangent lines that are parallel to the secant line, and it looks like that's about 2.5. The second one's around 3.5, and the last one is about 4.5, I'll say. All right, so now that we've drawn these, let's talk about the mean value theorem. The mean value theorem is a function f is continuous over the closed interval and differentiable over the open interval. There exists a point C within the open interval where the instantaneous rate of change equals the average rate of change. So this part right here is the slope of the secant. Slope of the secant. And this is what I have right here. So can we find some points, C's, where there's the instantaneous rate is equal to this slope of the secant? And that will occur right here. So we do have a point C here, and actually we have more than one because we have another one over here. So the mean value theorem says there's at least one C. This is one C, and then here's another one. At least there exists a point C. Now they don't tell us how many of them, but in this case we had 2 on my picture, but we can have at least C. Now this is a condition that it's continuous and differentiable. On the previous examples, the ones that didn't work were because they weren't continuous or they weren't differentiable in the interval. Let's take a look at doing an example here. We want to use this function to answer the following. On this interval, what is the average rate of change? So I'm going to do f of 6 minus f of 2 all over 6 minus 2. And when I go ahead and put that value in, it'll be negative 36 plus 18 plus 10 minus, and then putting 2 in, that'll be negative 4 plus 6 plus 10 all over 4, and that'll become negative 20 over 4, which is negative 5. So this is the average rate of change. Now, because this function is continuous and because it is differentiable, I can apply the mean value theorem and I can find an instantaneous rate of change that's equal to the average rate of change. So how do I do it? I figure out the derivative, and that derivative is negative 2x plus 3. And to figure out what that x is that I'm going to have, I am going to set my average rate right here, equal to my instantaneous rate. So I'm going to take negative 2x plus 3 and set it equal to my negative 5. That's my average rate of change. Negative 2x is equal to negative 8, and so x is equal to 4. So this answer is the place at which the instantaneous rate of change is going to be equal to the average rate of change. So if I put 4 into this derivative, f prime of 4, this will be negative 8 plus 3, which is equal to negative 5. And this instantaneous rate of change is equal to the average rate of change. All right, so let's take a look at these two big theorems that are used in calculus, the mean value theorem versus the intermediate value theorem. And I want you to stop the screencast, think about it, and then I'm going to continue and show you the difference. And here we go. The mean value theorem is telling us that this average rate of change, when the function is continuous and differentiable, we're guaranteed to have an instantaneous rate of change that's equal to the average rate of change, and that location of the instantaneous rate of change is in the interval. The intermediate value theorem says if you have a continuous function and you have two y values, then all the y values in between will exist. All of them will exist. Okay, let's take a look at a problem where we have to keep the two theorems straight. We have a hot air balloon that's launched into the air with a human pilot. The twice differentiable function h. Twice differentiable means that h prime, we're going to be able to find a derivative of h prime, and h prime will also we'll be able to have a derivative. That's twice differentiable. Okay, the fact that it's differentiable means that this h of t is continuous. Whenever something is differentiable, it is continuous. Okay, so if for 5 to 20, there is a time when the balloon is 50 feet in the air. Justify your answer. So between 5 and 20, we can see we have heights of 40, 70, 65, and 80. Now 50 is between 40 and 70. Now how do we go about doing it? Let's kind of remember. Remember, you need to say h of t is continuous, and you must claim that you have an intermediate value. So 50 is between the value 40 and 70. So by the intermediate value theorem, there exists a f of c equal to 50, where c is in between 5 and 15. So that is the use of the intermediate value theorem. Okay, let's take a look at this problem. For 20 to 30, there must be a t where the balloon's velocity is 1.5 feet per minute. So they're saying, are we going to be able to have an instantaneous rate that's 1.5? So let's take a look at between 20 and 30. Let's take a look at the average rate of change. All right, average rate of change, average rate of change. And that's going to be f of 30 minus f of 20, all divided by 30 minus 20. And so we have f of 30 is 80 minus 65 all over 10. And so this answer is going to be 1.5, and average rate of change is feet per minute. So this is the average rate of change. But because this is continuous, so this function is continuous, and it's differentiable, which are the requirements of the mean value theorem. By the mean value theorem, there is a f prime of c that will be equal to the average rate of change, which is 1.5 feet per minute. The mean value theorem does not tell us how to find it or where to find it. It's just that it exists. So we know that there's going to be an instantaneous rate of change that equals the average rate of change. All right, so let's kind of summarize again the mean value theorem. There are requirements for the mean value theorem. The function must be continuous and must be differentiable. Continuous, so there's no weird things going on. Differentiable, because we actually use a derivative in the outcome. And then there's going to be a C, where the instantaneous rate of change at C is equal to the average rate of change in the interval from A to B. Informally, the mean values theorem states that given the right conditions of continuity and differentiability, there's at least one tangent line parallel to the secant line. Or still in other words, the instantaneous rate of change, slope of the tangent, will equal the average rate of change, the slope of the secant, at least once. Okay, I'd like you to take a minute to stop the screencast and see if you can decide whether the mean value theorem applies, and if it does, see if you can find the C value. Do not use a calculator. Okay, and here are the answers. The first one, we say no, it's not differentiable because remember this absolute value has a point at which we have no derivative. The next one, we have yes, and we find the derivative. We find the average rate of change 2. We set the average rate equal to the instantaneous formula and then solve for x. The next one is yes. It's because this is going to be differentiable and continuous, and when it's differentiable and continuous, we can go ahead and set these equal to each other. And the last one is no, and it's because it's not differentiable. And this is the end of the screencast.